Alright, this video is going to be on adding and subtracting rational expressions. So before we do that, let's just go over one big rule of fractions. Whether it's adding or subtracting fractions, you need to remember I need a common denominator. If you don't have a common denominator, do not add anything together. So let's take, for example, 2/3 plus 3/5. Alright, so 3 and 5 are not the same number, therefore you cannot add these together. So we say, what is a common multiple between 3 and 5? Hopefully everybody in the room that is watching this video would say 15. That 15 is this number that I need to create. So how would I create 15? I would multiply the bottom of this one by 3. And what I multiply the bottom by, I multiply the top by. Because honestly, it's just a fancy 1. If you see that 3 divided by 3 is 1. So you're not changing the value. So 9 over 15. And then on this one, I'd multiply everything by 5. Once again, you've got to do top and bottom so you don't change the value of the problem. So it'd be 10. And then when you add fractions, remember you add the numerators, boom, 10 and 9, but you keep the denominator the same. So 15 is on the bottom still, and you have 19. And that is how you add some fractions together. You do the same thing for subtracting. So if it had been subtraction, instead of 19/15, it would be 1/15, because you would have done 10 minus 9, but you keep the denominator the same. Alright. If you can do that, you can do these. So, for example, check this out. Let's go with 2 over x plus 1, okay, plus 2 over x minus 1 minus 1 over x squared minus 1. When you look at all of this, you have to ask yourself, what is the least common denominator that I'm trying to achieve? If you get the least common denominator, you should be able to do this problem without much issue. But in order to get the least common denominator, you have to factor all the denominators. So when you look at the bottom here, this doesn't factor, it's just x plus 1. You look at the bottom here, it's just x minus 1. But this bottom can factor this denominator, so it's x plus 1, x minus 1. Now that it's factored, what you want to do is you want to basically ask the question, what is the least common denominator? Or another way to think of it is, what denominator could I create that would be the same for all three? And essentially it's right here. This guy, x plus 1, x minus 1, I could create down here and here in order to then add and subtract these things together. And so what you're going to do is you're going to multiply by what each denominator needs. And so when I look at this, if I'm trying to achieve x plus 1, x minus 1, this denominator here, the first one, needs an x minus 1. So I'd multiply by x minus 1 on top and bottom. The second one needs an x plus 1, so I multiply by that on top and bottom. And the third one doesn't need anything because it's already got x plus 1 and x minus 1. So this is what we've got. 2 times x minus 1 over x minus 1, x plus 1, plus 2 times x plus 1 over x minus 1, x plus 1, minus 1 over x plus 1, x minus 1. And I've got the same denominator on the bottom. Remember, order doesn't matter when you multiply, so whether you write x minus 1 or x plus 1 first, as long as they have the same factors on the bottom, you're good. Now to add them together, you have to be able to combine the numerators, but first you might want to distribute. And so we'd have 2x minus 2 over x minus 1, x plus 1, plus 2x plus 2 over x minus 1, x plus 1, minus 1 over x minus 1, x plus 1. And when we add things together, we're going to combine like terms. So on the tops, I can do 2x plus 2x. So that would give me 4x. And then negative 2 plus positive 2 is 0. Minus 1 is minus 1. So on the top, I'd have 4x minus 1. On the bottom, I'd have x minus 1, x plus 1. And that is how you are going to add or subtract rational expressions. Make sure you have a common denominator. Let's try another one. Alright, so let's go with something a little bit more exciting. Yes, this one is good. Alright, I promise. 1 over x, okay, plus 2 over x squared plus 1, and then plus 1 over x cubed plus x. Alright, so first thing that we want to do is factor, so that we can see what's on our denominators and see what we can do. So you look at x, can't factor it. It is what it is. This one's a good one because some would think we could factor x squared plus 1, but we can't. Remember, it's got to be x squared minus 1 if you're going to factor it. But that's x squared plus 1, so it's stuck. This guy, we could take a GCF out, and you'd have x times x squared plus 1. And so hopefully you're seeing that this would be the denominator because it encompasses both pieces of the first two, and that would be what we want to strive for. So I'm going to multiply now. Multiply by missing factors. And so the missing factors that I want to multiply by are, for the first one, I want to multiply by x squared plus 1. Sorry, I'm running out of room. X squared plus 1. And then on this one, I just want to multiply by x. And the top, or this third one, is good. So on top of the first one, we would have x squared plus 1 over x times x squared plus 1. Plus 2 times x, which is 2x, over x times x squared plus 1, plus 1 over x times x squared plus 1. And now that our denominator is the same, we can add the numerator. So we know what's on the denominator, x times x squared plus 1. But now we're going to combine like terms that are on the top. Nothing to go with x squared, so it is what it is. Nothing to go with the 2x, so plus 2x. And then plus 2. 1 plus 1 is 2. And there you have it. So you've added rational expressions. Hopefully that's helpful, and have a great day.